Start.
Hey everyone, I'm Rahul from Group 10,
My name is Alan.
I'm Anthony.
My name is Akshat.
and we're from this semester's capstone Group 10, and our project was on video customer service. So I'm sure a lot of you have been in a scenario where you're on the phone, frustrated with an agent because they're not understanding what you're trying to say, or you can't put it into words or whatever. So we thought what would be really awesome and ease the process of all of that would be to put it together, put together a system that would allow um, object detection to be able to determine something when something's wrong. So we decided to put together a system that would put different hardwares or appliances or whatever, and this is the application would analyze it and tell you exactly what's wrong and everything. So that's what we really wanted to put together, and but due to the coronavirus pandemic, we had to modify our approach, and so we decided to put the system to expand on some of the use cases of the system. So we expanded the electronics one as well as the sports activities, and with everything going on right now, we thought it'd be really cool to see if we can analyze X-rays if they have COVID-19 or not. So that's something that we thought would be really awesome. And Akshay will go ahead and expand on the use cases for that.
So based on the use cases that Rahul just explained, there are three places where we can see our application make a significant impact on industrial level. So starting from COVID-19 classification, if doctors interact with our application, they can receive receive X-rays electronically and make a seamless detection on narrowing down what diseases to focus on to help with their diagnosis of COVID-19 and various other diseases. For electronics, it can really help out in the IT industry where representatives can receive videos of broken electronics from the customers and they can direct them to proper agents and see what specifically is broken in the user's appliances so they can direct a proper troubleshooting scenario. And as a sports activity is concerned, coaches and fitness trainers can record videos of their athletes and other other coworkers and peers to see how their forms are, and they can help out and work out a proper training programs. And then now I'll explain the flowchart on how our application is supposed to interact when put together. So if this application was deployed on your phone as right now, you when you open the application, you will see a welcome screen where it will be asked for all the use cases that we have on our application. Once you select one of the use cases, it will be upload a video or record a video from your phone and send it to our system. Once you upload it, it'll be analyzing on the back. The video will be analyzed on the back end and create an appropriate prediction and give you a response based on that. And you would be presented with the what our system has predicted and give you proper information. And now Anthony will explain how our algorithm is structured and provide a proper demonstration of how it works.
Okay, so here there are two main use cases: electronics and COVID. For the electronics, we tested it three times, three separate models. The first model we started out with a data set size of, or a sample size of 300 pics per class. That yielded an accuracy of 55%. But we wanted to improve on that, so we tested it again for the second model. We use data augmentation on those 300 pics from Google Images to increase the sample size to 1,200 pics per class. And then that yielded an accuracy of 65%. And then for the final time, all we did was parameter tuning, namely dropout and pool size uh, changes. And for the COVID, you can see as the number of epochs increase, the accuracy plateaus to around 90%. That's just That makes sense, run it more. It'll train. And then I like to demonstrate this with some videos of the outputs of our testing. So the working mouse and the broken mouse, they work as well as the broken phone screen since the beginning. So right here, as you can see, there's no hardware defects. Everything seems intact. So it's just a computer mouse.
And yeah, so this is the output of the system. So the input is just the same video without the prediction on top, and the output is after it analyzes and predicts it, it gives us this prediction caption on the top, and that allows us to be able to determine what it is.
Okay, and then so working mouse and then the broken mouse right here. As you can see, it's taken apart. There's some loose parts in there. So it's going to detect it and say that it's a broken computer mouse. And then the broken phone screen right here. Glass is shattered, so it should detect as it does broken. And then the ones that didn't work, from this folder, these were the original outputs from the first model. So I'm going to do the laptop screen. So glass is clearly shattered, but so somehow it didn't detect it. And the broken laptop screen. This was the new model after all the parameter tuning. Finally got it right. Okay. And then we have the broken phone charger. That one didn't work. This wire strips should be saying broken, but it's not. And then right here, or near the end, it finally detects it, which is an improvement, better than last time. Okay. And then with that, I'd like to turn it over to Alan so he can explain the tools and technologies used for this project.
So for this project, for our front end, we use Android Studio to create a front end application. And then we had that running with a 000 web host, which stored all the pictures and videos analysis. We also had it running with AWS in the beginning, but then we stopped doing it because of cost. In terms of the algorithm, that's where most of our project went to. We use Python, which has a built-in keras library to perform many of our deep learning functions and methods for us, which saves a lot of time. And in terms of the neural network we use a ResNet 50, which is a very common neural network, one of the best neural networks that you can use nowadays. And then we use that for activity and electronic classification. And then for COVID, we use VGG because we compared it with ResNet, and it performed better in this use case than ResNet, so we stuck with VGG. And then in terms of getting actual classification, we run the neural network on each video. We take it frame by frame. We store those outputs into an array, and then we look at the past 124 to 64 frames, compute the average of all the outputs, and see which one had the highest probability. So let's say out of the past 64 frames, the most output that came out the most was broken laptop screen, and on the output video, it would show broken laptop screen as the output of that video. Now we'll go on to talk about future work. So for future work, a big thing nowadays is automatic speech recognition. So if you could combine that with that video recognition, it would allow our users to send more data, which allows us more information and allows a model to have better accuracy. And that means we can also have better results and be able to have more categories and more specific details for our users.
Another thing that we thought would be really awesome to implement was hand detection. So let's say a user has something specific wrong with like their dishwasher or something. They can point exactly to what is wrong with it, and they can instead of having our system analyze the entire dishwasher, they can analyze that specific part so that they can like, see exactly what's wrong and give tips on that part instead of just saying nothing's wrong because the high end view is fine. Um, the other thing that we thought would be awesome to add is pretty common thing. More prediction classes. As of right now, for our main use case, the electronics one, we have just 10 use cases. I mean 10 classes, but obviously we'd want to add more, and it wouldn't just be hardware detections. We'd hopefully try to add different things. We could train and use for future things.
All right, and expanding more on the future work, we're thinking when the prediction is, as of now, when the prediction is outputted to the user, it just gives a generalized comment like if something is broken or not. But we would like to expand it into more specific user responses, like if a phone screen is broken, like we saw, it should say like there's a cracked phone screen, or it's a cracked iPhone screen, or it's a cracked Android phone screen. Same thing with chargers or laptops. Like we want to focus on detecting specific model issues and specify what exactly is broken with the electronic rather than giving generalized comment. That way we can direct the user to appropriate troubleshooting locations and connect to an agent accordingly based on the models and scene scenarios by which we can create an efficient customer service using this application.
And with that, I'd like to thank Hannah Godrich and Shabab for their advice and in guiding us to get the results that we want for this project. And Shahab is from Interactions Corporation. So thanks to them. And thank you
Thank
for
you.
tuning in.
Thank you.